Hi, welcome back to this chapter, Atomic Structure. Today we are going to continue with 2.2, Quantum Mechanical Model. The first tutorial question that we are going to discuss is, first, define the orbiter. So, orbiter is a three-dimensional space around the nucleus whereby the probability to find an electron is the highest. So, probability in bahasa we say that it is kemungkinan. So, means that the chances for you to look for the electron is the highest. And then another, don't mix up with the orbit that we learned in chapter 2.1. So let's see what is the difference between orbit and orbiter. Orbit actually is a path, okay, of that electron at where the electron can be moved around. Like just now we mentioned, an orbiter is only a three-dimensional region in which an electron may be found around the nucleus. Okay, so now we try to use simple words to understand. Okay, I will consider that orbit is like a block of building, while the orbiter is a room. So basically, orbit is different with orbiter. Next, question C. Say all the four quantum number and what they indicate. Okay, simple words to say, quantum number is considered like IC number, okay, for electron, IC number of electron. Okay, and as usual, our IC number make up from three parts. Okay, first part is your birth date, and then the place that you birth, and then is your identity number. Okay, but for electron, each of the electron have four number. Okay, first one is principal quantum number. The symbol is N. While second quantum number is called angular momentum quantum number, which the symbol is L. Magnetic quantum number, symbol number is M, and electron spin number, symbol is S. Okay, like previously, I will use a simple analogy. Okay, so the principal quantum number basically is like at which block the electron stay. Okay, so angular momentum quantum number let us know which floor is the electron stay. And also the third one, magnetic quantum number, let us know where is the room. And the last one, inside the room, which bed does the electron stay. So if you still remember just now in question 1A and 1B, we treat block as orbit, while the room as the orbiter. So like you imagine, if you go to the block to look for your friends, or you go to the room to look for your friends, which one the chances is higher? So for sure, your friends stay at the room, the chances is higher than you just walk around of the block. Okay, if you know the room, then it will be easier for you to look for your friend instead of you know which block he or she stay. Question number 2. Orbitals S, Y, and Z with their quantum number are as follow. So once we look at the N symbol N, we know this is the principal quantum number, while L means angular momentum quantum number. Okay, so if you still remember, just now we say this is, let us know which block the electron stay, and this one is which floor the electron stay. Okay, so basically for the angular momentum quantum number, I will prefer students to remember, okay, L equal to 0, 1, 2, and 3. So here is S, P, D, and F. Okay. So now this one 0, so means that is 1s. 4 2 means is 4d. 5 1 means is 5p. Is it okay? Yes, very good. Okay, then now at the same time, let us check out, is this orbital are valid or no, or are available or no. So as we already know, L value always less than N value. So if now we check at here, 0 is smaller than 1, so 1s exists. 2 is smaller than 4, 4d also exists. 1 is smaller than 5, so 5p also exists. Okay, then next one we want to know, determine the maximum number of electrons, okay, that occupy in each of the above orbital. So after we know the block, the floor, and then we need to know each floor has how many room. So this room is magnetic quantum number, okay, where the value is negative L to positive L. Okay, for example, we have 0, so negative 0, 0, positive 0 means that all these are the same. So only refer to 0. So we have only one orbital. Okay, only have one orbital. Okay, while for the second D, so we have negative 2, negative 1, 0, positive 1, positive 2. So here we have 5 values, so means that there are 5 orbitals in 4Ds. Okay, 5p, p is L equal to 1, so we have negative 1, 0, and positive 1. So we have 3 orbitals. Okay, but this electron is asking us number of electron. And just now, followed by the S, the spin quantum number, which represent the bed. So we know that in every room, only maximum have 2 beds. So that's why if they ask us how many electrons, so one orbital, we will only can fix maximum 2 electrons. 5 orbital, maximum 10 electrons, while 3 orbitals, maximum 6 electrons. Question number 3, give one set of possible quantum numbers for an electron in 3s, 4p, 3d. Okay, set of quantum number. Again, quantum number means ID, IC number for an electron. And this IC number, when mentioned in set, means that they will consist 4 digits, which represent N, L, M, S respectively. Okay, so again, we just recall, principal quantum number is represent the block. Angular momentum quantum number is represent which floor the electron stay, while magnetic quantum number refer which room the electron stay, and lastly, spin quantum number showing that the electron stay at which bed. Okay, so why here have one set? Okay, we look at this one, 3s. Okay, 3s, so we know that the electron stay at the third block, and then is ground floor, okay, because L equal to 0, so let's say it is at the ground floor, okay, or which level. So because of this is at the ground floor, so at ground floor, L equal to 0, possible M value is 0. So means that again, only have one room at the ground floor. So means that maximum we only can have 2 electrons. One is positive half and another one is negative half. So what is the possible number for 3s? So it can be 3, 0, 0, positive half, or 300 negative half. Okay. Again, because the question say here one set, so you just need to give one set. Okay, 4p. So when I have 4p, I know that L equal to 0, L equal to 1 for p. Then the possible n value is -1, 0, and +1. So because of there are 3 rooms, so altogether they can be filled up to 6 electrons. So if have 6 electrons, means that we will have 6 sets of quantum number. But this question just want us to give one set. So the answer can be 4, 1, -1, +half. Okay, or 4, 1, -1, -half. Or 4, 1, 0, +half, or 4, 1, 0, -half. The third room, 4, 1, +1, +half. Third room still have one more bed, 4, 1, +1, -half. So you just need to give again either one set. Okay, one set only, one set only. Okay, the last one is the 3D. Okay, so if 3D, so we will have the idea L equal to 2. So possible n value is -2, -1, 0, +1, and +2. So mean for 3D, I can write 10 sets of quantum number. Okay, so I won't repeat all, so I just randomly 3, 2, -1, 0. Is it possible? Yes, it is not, because the spin quantum number is either +half or -half. So if 3, 2, -1, +half, yes, this is possible. Question number 4. Which of the following orbitals are not allowed? And then explain. Okay, let's look at the first one, 2D. So before we want to start, just recall back. Means that 2D, the D allow us to identify the angular momentum quantum number. So to make it easier, I will always ask students to write out as P, D, F, G. And then maximum 5. I think is more than enough. And then 0, 1, 2, 3, 4. Again, next things that we need to alert, because we know that L value is always 0 to n minus 1. Okay, therefore, as long as L value is less than n value, means that it is allowed. So this one is n equal to 2, L also equal to 2. So in this case, 2D is not allowed. So how we are going to explain? So we can say like this. When n equal to 2, possible L value is equal to 0, 1. So L equal to 2 is not allowed. Okay, this is how we do the explanation. Second, 7s means that n equal to 7 and L equal to 0. So very obvious, 0 is less than 7. So 7s is allowed. 1D, n equal to 1, L equal to 2. So again, we can use the same method. When n equal to 1, possible L equal to 0. So L equal to 2 is not allowed. Last one, D 4P, N equal to 4, L equal to 1. So L less 1 smaller than 4, so 4P is allowed. Question number 5. Which of the following orbitals are not allowed? Again, we need to do the explanation. So basically, again, one set of quantum number is made up from N, L, M, and S. Okay, so normally when I do this question, as long as the N is whole number, so N value in this case should be no problem. All are possible. L value must be always less than N. So when we look at here, this one, the A less than, B no, C less than, D also less than. Okay, so means that I already get the idea why B is not allowed. So we will say when N equal to 1, possible L value equal to 0. Hence, N equal to 1 is not allowed. Okay, so we already settle for question B. So we can remove B. Okay, already settled. Okay, the third one is the M. M is referring to magnetic quantum number at where is negative L to positive L. So if L is 1, M is negative 1 possible. This one 0 also possible. 0 also possible. And then for S, we only have either positive half or negative half. So the set A, the spring quantum number here is 1. So this is not possible. So let's do explanation. Okay. S is either positive half or negative half. Hence, S equal to 1 is not allowed. Okay, so and then we continue with C and D. Yes, positive half, positive half. So set C and D is possible and A and B are not allowed. Question number 6. Give all possible value of L and M for 3P and 4D. Okay, so let's start with 3P. So from 3P here, we know the possible L value is 1. Okay, due to L equal to 1, hence M will equal to negative 1, 0, and positive 1. Okay, another one is 4D. From the D here, we have the idea L equal to 2. Once L equal to 2, M will equal to negative 2, negative 1, 0, positive 1, and positive 2. Next question, 7. Draw the shape. Okay, so highlight here is the shape for the following orbital. So as we all already know, S orbital always is in sphere. Okay, the shape of sphere. So 1s and 2s. So beside, you need to label x, y, z axis. What is the orbital? 1s and 2s. So what's the difference between 1s and 2s? Basically, is the size. If you look at 2s, is larger. The size of the sphere is larger than the 1s, the size of 1s. Okay, while question B, 2px, 2py, and 3pz. So again, if your label of the axis is PS, so you have to make sure the dumbbell is on the x-axis. While for the PY, the dumbbell is on the y-axis. PZ, the dumbbell is on the z-axis. Again, the difference between the 2PY and the 3P is in terms of size. Okay, the higher the n value, the larger the size of orbital also will become larger. Okay, so we have three types of p orbital: px, py, and pz. Okay, while the last one, for d orbital, dyz, dxz, and also dxy. So again, when the orbital is when the n is equal to 3, the shape of the clover leaf is smaller. But when n equal to 4, the clover leaf have to draw a bit bigger. So xy, xz, yz, to show that the 4 loop is in between the two axes here. Okay, so next thing that we need to highlight here is angular momentum quantum number represent the shape. Okay, while the principal means that the n value represent the size. Okay, n value represent the size, L value, angular momentum quantum number, represent the shape. Okay, so this is the answer for tutorial question 2.2 objective. Okay, that's all for 2.2. Hope to see you again in 2.3. Thank you. Bye.